Bismillah ar-Rahman ar-Rahim. In this video, I would like to solve example 8.5. The question states, find the coordinates of the stationary points on the curve y is equal to x squared plus 9 over x and use the second derivative to determine the nature of these points. The question demands that we need to find the coordinates of the stationary points. This is the first thing which we need to find out. And once we have found those, then we will use the second derivative to determine the nature of these points. So let's start with differentiating this equation first so that we can find the stationary points. So y is equal to x squared plus 9 over x. Now this equation apparently seems to be a quotient rule, but as you can see that the x is a common denominator, so we can actually simplify this equation as y is equal to x squared over x plus 9 over x, and this simplifies to y is equal to x plus 9 x to the power negative 1. So this is the simplified form of equation y. Now we will differentiate this with respect to x. So dy over dx is equal to, differentiating x is going to be simply 1. Differentiating 9, x minus 1, so simply we multiply 9 with negative 1, so we get negative 9, and we would like to decrease the power by 1. So this is the differentiation of this equation. Now we are going to put the equation equal to 0 in order to find the stationary points. So dy over dx, will put it equal to 0, which is equal to 1 minus 9x to the power negative 2. We can rearrange this equation for x, so let's bring this to the other side. It becomes 9x to the minus 2 equals to positive 1. And we know that 9 can be written as x to the power 2 is equal to 1. Bringing this to the other side, it is equal to 9x squared now. In order to find the value of x, we are going to take the square root on both sides. So plus and minus 9 is equal to x. So we get the value of x to be plus and minus 3. Right, so these are the two points which are known as the stationary points. Now once we have found these stationary points, we need to actually find the value of y now. So let's find the value of y. Simply what I'm going to do is take the value of x to be 3, and I will substitute that value into this equation in order to get the value of y. So let's do that. We have y at 3 is simply equals to 3 plus 9 3 to the power negative 1, which turns out to be simply 3 plus 9 over 3, which is going to be 3 plus 3, and that turns out to be equal to 6. So that's first coordinate of y. We can do the same thing to find the value of y when x is negative 3, and if we do substitute the value, we will see that the answer is going to be simply negative 6. So y at negative 3 is negative 6. So the two coordinates which we were looking for are as follows. Number 1, when x is 3, the y value is going to be 6, and when x is minus 3, then y value is negative 6. Now these are the two stationary points which we were asked to find. Now let's clear the board because I'm running out of space. So let's move on and find out the nature of these points. Right, these were the stationary points which we just found, and this is the equation for y, and this is the equation for dy over dx. Now I'm going to find out the second derivative. So let's differentiate the equation again. So we have a second derivative as follows. Differentiating 1, it's going to be 0, and differentiating negative 9 x to the negative 2 is going to be simply 18 x to the power negative 3. Now since we have found the second derivative, we are going to substitute the values of x into the second derivative in order to find out the nature of these points. So let's start with the first one, the value when x is equal to 3. So y double prime, which is the second derivative, at 3 is equal to 18, and I'm just going to write x to the negative 3 as 3 to the power 3. And if we simplify this, we can see that it turns out to be 18, 3 to the power 3 is 27, and 9 goes into 18 twice, and it goes into 27 3 times. So y double prime at 3, we can see that it is a positive number, so which implies that since y double prime at 3 is more than 0, it implies that it is a minimum point. Right, let's do the second one with the same way. Y double prime at negative 3 is equal to 18 over negative 3 to the power 3, and this time it is going to be 18 over negative 27, and when we simplify this, it turns out to be negative 2 over 3. So once again we say that since y double prime at negative 3 is less than 0, it implies that it is a maximum point. So we come to the conclusion now that the points, this one at x is equal to 3 is a minimum point, and x is equal to negative 3, it is a maximum point. Right, thank you very much for watching the video. I hope you enjoyed it.